Welcome to Study Loop.
So here we need to know the definition of a limit point. A point X is a limit point of a set if every open ball centered at X contains a point S other than X itself. Now let's consider our statement that every point of S is a limit point of S. We see that this statement is going to be true for any open subset of S of R3. To see why, let's suppose that X is a point in S. Since we know that S is open, there exists an open ball, B XR, centered at X that is contained entirely within S. Since this BXR contains infinitely many points, it must contain at least one point other than X. Therefore, we see that X is X is a limit point of S. So we see that this statement is also true for any metric space, not just R3. Our proof is going to be essentially the same as above, using the definition of a limit point. We see that the fact that our open balls are defined in the same way. When S is closed, the statement is not true. For example, if we consider that S is equal to 0 and 1 over n, where n is our natural numbers, we see that this set is closed in R, but the point 1 is not a limit point since there is no open ball centered at 1. Therefore, we see that our given statement that every point of S is a limit point of S is true for both our subsets of R3 and our general metric spaces, but we see that it's not necessarily true for our closed subsets of R3 or general metric spaces.